All right, good afternoon, everyone. Is everyone enjoying this weather or what? Yeah, good, excellent. Welcome to the Community for Rigor. This talk is part of the C4R25 Conference. It's the only conference focused entirely on scientific rigor. And it's happening today and tomorrow here in Philly. For those of you who don't know what the Community for Rigor is, we are an initiative funded by the NIH and its National Institute of Neurological Disorders and Stroke, NINDS. We're based here at Penn, at Research Building, so if you want to come pay us a visit, we're right there. And we are creating a free online curriculum to teach, learn, and promote scientific rigor. So basically from A to Z, everything you need to know and the skills you need to acquire to do more reliable, reproducible, and transparent science. Now, we're not the rigor police or the integrity police. We're not here to tell you point fingers or question the quality of past or present research. We're here to help you do better science and teach you every step of the process while helping you acquire the skills that everyone assumes you already have. Just as importantly, we're here to bring together a global community of people who care about doing good science. As much as it is a set of processes, rigor is a mindset, an everyday practice. And our goal here is to provide you with the tools and the community to help you develop that mindset. And with that, I will introduce you to our panel. You'll hear first from Ivan Oransky. He is the co-founder of Retraction Watch and also the editor-in-chief of The Transmitter, among many other things you'll see in his presentation in a minute. We also have Anita Bandrowski. She is the co-founder of the Resource Identification Initiative, RRID. She's going to explain a little more about that. It's all about reproducibility. And then we have Jason Williams. He's the Cold Spring Harbor Laboratory DNA Learning Center Assistant Director, and he is one of our advisors at C4R. So with that, I'll leave you with Ivan, please.
Thank you very much, Caro, and thanks to all of you for being here. Really great to be here and glad to be talking about this issue. I actually I'm going to go back for a moment and just point out that, there are clear signs of image manipulation on this slide because Jason and I both apparently, removed our facial hair before we had these pictures taken, or maybe the other way around. Anyway, little light way to start. So I'm going to talk to you a bit about retractions. As you heard from Caro, I'm the co-founder of Retraction Watch and the executive director of the Center for Scientific Integrity, which I'm going to say more about right at the end of my presentation, give you a sense of what other things we do. But I'm here to tell you that, you may be thinking it's bad news that retractions are everywhere, that you're hearing about them all the time, that you're hearing about sort of bad science or bad intentions or bad motivations. And that's true, that there definitely is a growing number. There are more of them. But I'd actually like to maybe try and, flip your thinking a little bit about why that might not be bad news. It might actually be good news. And I don't know that I'm going to convince you of that, but I'm going to present, a little bit of data and a little bit of evidence and a little bit of argument about why that might actually be good news for rigor, for scientific rigor. So hopefully you came here with an open mind about these sorts of things. So the first is, and I apologize, this is one of these things where it's kind of like sending your slides through some software and then sending them back. They were apparently too large because I'm not very good at compressing files or JPEGs or whatever it is I was using. So they're going to all look a little bit off. It's not your eyes. It's not some sort of weird neurological condition that you have. It's actually that's me and my neurological condition about inability to create good slide decks. So this is a graphic from Nature earlier this year. Nature from the journalism side of Nature, in other words, the sort of news side. not the peer-reviewed side of Nature of the manuscripts, but they do a really good job. And Richard Van Noorden, who is the main writer on this article, does a really good job with not just writing about retractions, but other related issues, but particularly with retractions. And so what this shows, I think, pretty clearly, is that the rate of retraction, so not just the overall number, right? If you have more papers, you would expect there to be more retractions. That's if there's sort of just a linear relationship, but it's actually not a linear relationship. It's the slope is actually much higher than the rate. And if you were to go back in time, this actually continues. These data are mostly from the Retraction Watch database, which I'll say more about a little bit later, but also from some other sources. And so the two, if you will, parsimonious explanations for why the rate, and again, I want to just be clear that it's not just an absolute number that's increasing, but the rate of retractions increasing, to me anyway, are the one is that the reasons for retraction, in other words, and most of them, about 2/3 of them, are due to misconduct, some kind of falsification, fabrication, or plagiarism. That's the federal definition. So either that's growing, right, and there are more papers that should be retracted, or people are looking for these problems, right? So if you were to think about, for example, a screening test, so sort of you can think about this as a metaphorical screening test. If you never screened for a particular, say, cancer or other condition, the rate would seem to be much lower than it really is. Now, screening tests have their own issues. I'm not here to sort of have that discussion, although it's fascinating, false positives, what have you, but the fact is that they pick up more cases. So you're going to see an increase once you actually add a screening test. And in the case of retractions and scientific misconduct, which is, again, responsible for about 2/3 of retractions, the sleuths are the people who are the screeners. They're really doing it. It's sort of like they're the colonoscopists or the sort of mammographers of isn't that great? This is why the other thing I do that that's on my slide somewhere, but is I teach journalism at NYU, New York University. And you've already learned why I never use metaphors in my teaching, and I leave that to my students who are better at it. In any case, the sleuths are, largely individuals who are looking for problems in the scientific literature. These are people who are, doing, one might argue, work with rigor. They're looking at other people's work when they're looking for rigor or lack of rigor. And I won't sort of bore you with all this detail. You can actually, this is just a couple screenshots from Retraction Watch, which is, again, the website that I co-founded 15 years ago. But these are all people who specialize in finding different problems in the literature. So Elizabeth Bick, you can't really see her photo there, but that's sort of on the left. She's very, very well known for image manipulation detection, right? And so people who, they duplicate images, or they, fudge images, or they flip them and they sort of cut and paste pieces of them and all of that. Michael Dougherty, the top right, actually looks for plagiarism. He's a philosophy professor, a theologian and philosophy professor. He actually found a lot of plagiarism in work done by a Vatican deputy, which we can have another discussion about that. I think one of the 10 Commandments, thou shalt not steal, but, maybe it's okay if you're at the Vatican, I guess. No disrespect. Disrespect to that person, but not the rest of it. But anyway, so these people sort of speciate, these sleuths speciate. And so some of them, again, find whether it's plagiarism, statistical anomalies, other problems. And so, again, they've become kind of the screening test. So, okay, so again, you're like, well, okay, that's great. Now they're finding more problems. There still very well may be more problems, and they're probably, at this point, we're sort of getting more and more comfortable saying there probably are. But one of the things that I actually see as good news is that a lot of journals have started, not a lot actually, but a fair number of journals have started hiring people to look for these problems, either before papers are published, or in the case that we were writing about, Adam Mark is my co-founder of Retraction Watch, this is about 7 years ago now, actually after papers were published, because these journals were getting lots and lots of emails and, something called pubpeer.com, where a lot of people post things that they find that might be problematic, allegations, and they were finding them and they were sending them all to the journals, and journals had no staff to deal with them. They really weren't set up to do this. And so it's actually a good idea. I mean, it's good news if you are into rigor. It's not great news if you're into misconduct, right? So you have a higher chance of being caught now, which still, it's pretty small chance. And again, this is my apologies for, I'm glad I remember what's on that left one. You're going to have to, just sort of take my word for it. But these are two examples just to show you front page stories in New York Times and Wall Street Journal about scientific misconduct. And so, again, you could argue, if you are trying to hide the fact that there's scientific misconduct or don't want people to talk about it, that that's bad news. I would argue it's pretty good news. Also, I was quoted in both those stories, so of course I think it's really good news. But in all seriousness, like, this is, people are noticing. And so I think one of the sort of questions that people are thinking about now, and I would say pretty sort of some of the fairly loud debates that are happening now is, well, should we be talking about these issues now? Now, we've been hearing some version of that question since we started Retraction Watch, and other people long before we started Retraction Watch have been thinking about it. But of course it's just, let's not ignore the elephant in the room that we're in a particular time. One of the other things that's happening is that, and again, I guess I should have set this up a little bit in terms of like the media and in terms of the markets. So I started there with talking about journals sort of some of them actually taking this on. So that's sort of like science itself, if you will, or at least publishers themselves sort of doing something about it. I would argue they were pushed. But the problem when you sort of don't take things into your own hands, right? Problem when you don't self-regulate or police, we heard the word police already today. When you don't do those things, is that other people will come in and do them, probably in a way you don't like, which, let's face it, that's what we're seeing right now, maybe for different motivations. So the media is serving some of that purpose. I'm not saying they're doing all the job, but they're doing a great job, but they're doing something. The markets also, okay, this is something that I think it may not even occur to that many researchers. And when it does, it may make them uncomfortable. This notion that they are within the sort of, whether it's a free market or whatever kind of capitalist system. Well, guess what? A lot of the major publishers that you all who are, publishing papers at, who own the journals that you're publishing at, they're publicly traded companies, which means there's a whole other couple other arms of the U.S. government, for example, other governments, that are going to actually enforce some of this. And so you may have heard about a publisher called Hindawi, which was bought by Wiley. Again, that one you've almost certainly heard of, a fairly large publisher. Well, it turned out that Hindawi special issues, they're called, were overrun by paper mills. And so they had to retract over the course of about 18 months. Hindawi had to retract 13,000 papers. Right, so I told you I'd tell you a little bit about this Retraction Watch database, just a little bit of throwing that in there. Right now, and this is about a year after all this has happened, sort of finished happening, right now there are like 61,000 retractions in the Retraction Watch database. So 13,000 of them are from an 18-month period and one publisher. Like, if you were studying that, right, which people have, if you were studying that, you would like exclude those data as some weird outlier thing, right? And yet that's whatever 20% of retractions since the history of retractions. By the way, since we're here at Penn, I'll just tell you a quick little story, which is I probably actually we had something at the Franklin food hall or something. There's Franklins everywhere here, right? So the very first retraction in the English language, right, involved Benjamin Franklin. It was in 1756. It was actually a retraction of someone questioning Benjamin Franklin. Franklin turned out to be right. I'm not saying he was right about everything, but he's right in this particular case. So this other, Benjamin Wilson, his name was, not Benjamin Franklin, he had published in the Royal Society. We were still we were still a colony at that time. So it was Royal Society proceedings, and someone published a paper saying Benjamin Franklin was wrong. Turned out he was wrong. So he very graciously actually published a retraction of his claims. And that's the very first, in 1756, retraction in our database in the English language. Again, among other organizations and institutions that you probably don't want to have in your business if you can avoid it, right? Governments are taking note. So this was Dorothy Bishop, who some of you may know her work and about her really incredible and important work. She and I both, and a number of other people, gave testimony to this committee in the UK, the UK Science and Innovation Technology Committee of the House of Commons, and they actually came out and said, hey, it's taking too long to correct the record. Now, again, is that something that the UK government should be taking on? Is it something that any government should be taking on? Or has there been a vacuum where the scientific community or publishers or some version of that, however you think about it, hadn't been doing what they should? Well, so now let me sort of give you a couple quick examples of people who are, again, taking this into their own hands in what I would argue is a very courageous way. And then, if you are acting with rigor and you do something courageous, sometimes that's actually going to hurt, right? And it might hurt your career. These are cases where it didn't, I'm happy to say. Some of you may know the case, it's variously referred to as Pruitt-gate, Spider-gate, if that rings any bells. This was a spider biologist, but really an evolutionary sort of social looking at this behavior of spiders. And he would go out in the field or allegedly collect all these data and then share them with people like Kate Laskowski, a junior faculty member who, and it turned out let's just say no one's quite sure where those data came from after a while. And so she very publicly, before she kind of had to, made this public and said, hey, I'm retracting papers. By the way, now has tenure, all the things that you would hope someone acting like that. Similar case here. This is a quote from him. I felt like a fraud. These are all cases we covered at Retraction Watch. And, but he did the right thing, right? We actually have a category in Retraction Watch called Doing the Right Thing. He's obviously in that category. This was a little bit more, I don't know if poignant's exactly the right word, but, and these were two very senior researchers who, like, none of the tenure stuff really mattered at that point, and it was really sort of about scientific legacy. But there was this one part of this one researcher's legacy was finding a lungless frog that turned out, in retrospect, to have a lung. So, somebody else came along, someone he knew actually came along and sort of redid looked at the anatomy again and found that it was wrong, and they retracted it. Okay, that happened. Sometimes this sort of thing will happen. It's really no fault of your own. And anyone, I don't know how many of you work in sort of labs that use a lot of mice or other model organisms, but I've actually looked at, and I think they've made them a bit better, but when you order mice from, whether it's Charles River or Jackson Labs or whomever, the nomenclature is so complicated that it's actually not impossible. It's not difficult to order the wrong mice. And you end up and you do these experiments and everything works perfectly, except it's actually working perfectly opposite of the way it should. And we've had a couple cases like this where people just come forward. And by the way, these are the sorts of mistakes that no one's going to notice except you. Right. And this is maybe a common thread, because you can publish the paper. The findings are real. It's just that you had the wrong mice, but they came forward and did that. The cool thing is, and this is where, if it's nice I trained as a doctor, which isn't really a scientist. We all know that. Medical doctor, I mean. And so, I'm some guy standing up here and telling you that you should all behave better. And yeah, that's really great, Ivan. That's nice, and whatever, you can go home now. Since many of you hopefully are, motivated by, in fact, I'm sure all of you are motivated by evidence and data, I'm going to share some with you that I hope will, persuade that part of your brain. Don't ask me if it's the right or left. It's probably kind of a metaphor anyway. But economists love to look at retraction data, and they like to look, at retractions because it's about behavior, and it's also a relatively small data set, right? For an economist, that's looking at GDP, this is pretty small. And what they're able to do, and this is just one study, but several different groups have replicated this finding or reproduced the findings. When you retract a paper for misconduct, and it says something in the retraction notice like fraud or misconduct or something like that, your citations go down. In fact, your whole subfield kind of takes a hit, which isn't very nice for everybody else in it. But when you retract a paper for, again, honest error, like any of these people, and it says very clearly, hey, we found this error, we came forward, you actually don't see a decline in your citations. So it's as if that's sort of not built into the reward system exactly, but built into the kind of psyche, right? The consciousness of, behaving well, acting with rigor. This is sort of acting with extreme rigor, if you will. I know we're going to talk about a lot of other things here that don't involve, misconduct or what have you. It actually kind of helps you. And then I'm going to wrap up here just very quickly with a couple last slides. I just want to say that one of the things you probably don't want to do is cite a retracted paper. right? I mean, and if you do cite a retracted paper, you want to say it's been retracted, and that might be the point of why you're citing it, and that's, of course, all fine. But you don't want to cite a retracted paper as if it had not been retracted, right? Well, it turns out, and this, again, this is work that's been reproduced, 95% of the time in the biomedical sciences, retracted papers are cited as if they had not been retracted. 95%. That's not like sort of, oh, somebody made a mistake here. I mean, it's almost like people are making a mistake when they do notice. And there's a lot of reasons for that. One of them is that publishers are really quite terrible at marking papers as retracted, so even if you check. So I have some good news for you. This is the closest you'll get to an ad from me, even though it doesn't really help me financially. So the Retraction Watch database has been ingested now that it's actually part of Crossref, so it's completely open. You can go play with it yourselves to your heart's content. It's been ingested by all this software and lots of other software as well. And so you'll get alerts. If there's something in your library like that Zotero, which is open source, EndNote, et cetera, you actually can, you'll get an alert, an automated alert. You don't have to do anything. And like, hey, this paper's been retracted. You might have cited it once. Maybe you were trying to read it. Maybe you just thought it was interesting, so you popped it in there. Just so you know, might as well, especially Zotero, because it's free and open source. And then finally, just if you will, maybe I guess a word from my sponsor, not all of your sponsor, but, and I'm sorry, again, this is kind of hard to read, but I just want to just give you a, just sort of let you know where I'm coming from as I close here. But so Retraction Watch is one of 6 projects at the Center for Scientific Integrity. We're a nonprofit based in New York. I'm the executive director. The database is obviously another project that's part of it. We have a couple sleuthy projects. One is a fund that Elizabeth Beck actually set up with us based on some prize money. We have a Sleuths in Residence program, and so it's a very part-time sort of program where you can kind of do your thing, get paid a little bit for it, and get insurance coverage, which, by the way, is kind of an important thing, at least in my world. And we have something called the Hijack Journal, so I won't get into that, but happy to answer questions, what have you. And the one we just launched is called the Medical Evidence Project. James Heathers is leading that, and he's looking for studies that actually make a difference in terms of guidelines and systematic reviews and things like that. And actually, he's found some, which we will be publishing on, in due course. But we're really growing, and I'm thrilled about that. We've been around Center 10 years, Retraction Watch 15 years, and happy to say more about any of that. But I think I will turn things over to Anita now. Thank you.
How can I follow this except with some more fairly crappy slides? All right. So it really doesn't matter who I am. It doesn't matter really what I do, but I do really deeply care, and I hope that I convince you to also deeply care about research resources and reagents. And so what I was asked to talk about, and what we'll be discussing for the rest of the panel, are some of the good news for rigor and reproducibility. And the RRID project, right, is actually what I would argue probably some of the best news, other than retractions going up, for rigor and reproducibility. Now, we've probably seen this Nature article or some others talking about the reproducibility crisis as it pertains to papers that have used bad antibodies, right? So if you use a bad antibody, the argument goes, you're actually not doing the study. You're not detecting the thing that you think you are detecting. And so RRIDs just ask us which resource was actually used in this paper, so which antibody was used in this paper. And it can answer what other papers actually used this particular resource or antibody. All right. Why does that need to happen? Well, it turns out that this is a relatively recent paper. And these, I will argue, are becoming more rare. Well, this little, no, that's all right. Oh, the little arrow, yeah. Yeah, okay. So what happens here in this particular paper, which, the actual paper portion of it you haven't seen because I'm hiding that from you, but this happens to be a relatively standard method section. It's talking about the use of a mouse anti-flag antibody from Sigma. And then when you go to Sigma, there are 17 of them. Now, this is one of the things that tends to happen. If you are trying to reproduce that study, you can't. So RRIDs are something called a persistent unique identifier. And these are for key biological resources. So if you were actually to look at a different study that had an RRID in it, it would look something more like this. So instead of just saying Sigma, whatever antibody, it would actually contain the full name of the company. Ooh, let's go back. Full name of the company and this RRID, which is literally just RRID : and then some letters and some numbers afterwards. And that magic thing about this RRID, right? What it does is it actually marks those mice. You may be using the wrong mouse. Plasmids, pigs, we even have pond scum, but also antibodies, right? And so these are the sorts of things that are used here. And now here's the real good news. So we did a big text mining study now a few years ago, and using identifiers. So we started the RRID initiative here in 2014, and I hope you can see that. That's that purple line right there. And what that blue line, that big long blue line, this is the overall literature. And what is that? That is the percentage of essentially catalog numbers that are associated with an antibody. In that study, there were about 315,000 antibodies that we looked at. It was a big text mining study, and the thing we did for the 97 antibodies and the 2019 antibodies was exactly the same. And the sad thing is, way back in 97, is that between about 10 and 15% of the places where we saw an antibody was cited were actually cited along with a catalog number. So like I showed you before in that slide a couple of slides ago, this was the absolute common case. That's 85 to 90% of the studies. But what started to happen is that we had some of the big journals join the initiative, including Cell and eLife. And they actually brought the findability percentage of their antibodies from this kind of average 20%, 15, 20%, all the way up to 90%, which is kind of cool. And what that did is it actually brought up the average quite a bit. And then you could even see that journals which really didn't, follow our guidelines, they're starting to get pulled up in 2019. And I have to tell you that I had to search pretty hard to find that example in a recent paper. So that is a good thing. That is actually a good thing. Now, is it actually that all authors are now using RRIDs? No. But they're doing a whole lot better than they have been. This is a study we just published in PLOS One showing, and what I'd like to get you to see there is the orange, right? If you look at that orange plot, this is every single paper that cited an MMRC mouse. We looked at the mouse repository. This is one of these repositories with the giant names for the mice, right? And what we found is that there are basically 4 different kinds of citations that you could have to these mice. First one up there in the orange, nicknames. You know that Bob over in Penn? I like him. You know what I'm talking about? Yeah. That's the nickname mouse, right? That mouse, when you look in the MMRC repository, does not have a single mouse associated with that nickname. It's got maybe multiple, it might have none. So those papers are not reproducible because of this one thing. You can't find the mouse. And then what you see is that name is provided. So there's the long name for this mouse, and they're quite long. And you should really see flies. Flies are terrible. I mean, flies are wonderful, but their names are really, really bad. So the name's provided right here. And so our curators were able to find those. And then the catalog number. So here's a catalog number, the stock number for that particular mouse, and then here's the RRID. And the cool thing about the RRID is that one is actually machine actionable. Everything else is something that you may or may not be able to find using human beings as curators. If you are looking for that study, you know, those kind of blue-gray categories, you're going to be fine. You're going to find those guys. The orange, you may or may not, you might have to go back and ask the original authors, which actually is, if you look at the cancer reproducibility study, 0% of those original papers had a method section that was detailed enough to actually reproduce or attempt to reproduce the work. 0% were in kind of this this blue state, right? So what you're seeing there is actually RRIDs are not replacing the catalog numbers if you look over time. RRIDs are replacing the nicknames. This means that there's been a pretty big shift in how we talk about the things that we use towards reproducibility. And that, I really think, is some of the best news that I could ever talk about. Forget about me, forget about everything else. Talk about your mice. Talk about your antibodies. Don't worry about anything else. Talk about your reagents and resources. Now, there's something really cool if you have a bunch of people looking in a single place to find their identifiers for reagents and resources. It turns out that not all of them are good, much like there are retractions in the Retraction Watch database. There ought to be some retractions and reagents. There are cell lines that are non-authentic. There are cell lines that are just fine to use, but are actually known to be incorrectly labeled. How do you get a cell line that's incorrectly labeled? Well, it turns out a cell line often comes from a person. A person gets a biopsy, and you've seen people with cancer, right? They get misdiagnosed all the time. Now you can imagine this person gets misdiagnosed, they get a biopsy, they get that sample, that goes onto a dish, that metadata is stored with that sample, and it goes on to some shelf. People pick it up, they use it, cool. That was the wrong cancer. Because you can go back later and you can figure out, oh, right, that wasn't a hepatocarcinoma, that was a hepatocytoma. Perfectly fine cell line, used perfectly well, wrong cancer. Wrong metadata. So if you have a place where a lot of people come to understand and just to literally write down, find their stupid number, right? Find their stupid RRID number, you can intervene with authors without doing anything. You can just put in little notes. This cell line is contaminated. You ought to think about not using that, potentially. So when we did this intervention, what we found is that there was a 66% decrease in the use of problematic cell lines. And then we looked at those 50 papers that specifically used a cell line that was problematic. Only one author had actually knowingly used, ignored that warning, used a contaminated cell line. The rest of those 49 papers, one of them actually had a cell line that was contaminated, but that contamination event was discovered after the publication of the paper, so the author could not have possibly known. And the rest of them were using cell lines like the HepG2, which is one of those cells that had the misinformation listed. And when we looked at those papers, all of them were using HepG2 in the appropriate way. They were using it as a liver cancer cell line, which it is. So this intervention, this very simple intervention, at the end, when people are publishing their papers and they're looking up these numbers, this is after acceptance of the paper. The journal editor goes, oh, go find your RRIDs. And they're like, oh, okay, we'll go find them. But guess what? Those people pulled those papers. They changed their papers. They fixed it because we don't see those. And that, again, I would argue, is really good news. All right, so we work, so I founded a startup and also very recently founded a nonprofit. So RRIDs.org are now a nonprofit, We don't have all the cool logos yet, but we will. But we also founded a startup because we work with a lot of journals. And this is a tool that we actually created thanks to NIH very generously giving us some SBIR funds. We actually created a tool for journals. And that tool for journals gets RRIDs, right? And actually that you can see that key resource maybe you can, okay, trust me, there is some key resource adherence table here, and there are blue and possibly yellow and orange dots, and that means that you either have good resources or bad resources, okay? Cool. But of course, if you work with journals, they also care about many other aspects of reproducibility, as many of you do. And so we had to write classifiers and create classifiers for things like your ethics statements, for other rigor adherence qualities such as replication, code information, attrition, inclusion, exclusion, statistics, and other fun things. And so we mark all of those. And actually, the cool thing about this particular report is if you keep looking down at subsequent portions of this, there are things like randomization. And then there's you didn't randomize or you didn't tell us how you randomized this study. Here's a set of information that we have on randomization. Here's what the tool does to recognize these sentences for randomization. And then here are some really cool things that C4R has about randomization in terms of if you want to learn more about it. So we've already started linking these reports back into your work. And now these things get run quite a bit. You probably, unless you've submitted to a journal that actually enforces this, you probably wouldn't know that this exists. But if you've submitted to something like American Association for Cancer Research or American Heart Association journals or one of those, you'll actually probably have seen one of these reports, which is cool. And we know that, about 300,000 people have seen these reports now, or at least 300,000 reports have been seen. So to be fair, I think that this is a really good way to shed a light on what you guys are doing as well as part of that learning about some of these rigor things. Okay, cool. And so I mentioned, and this is my last slide, I just mentioned that the American Association for Cancer Research has actually implemented SciScore as a way to ask, because here, let me see if I can get this little point, not very good. All right, but if you see January 2018 here, and January 2019, so right around January 2018, when there's 0 publications with RRIDs, that is when they actually put in the instructions to authors for including RRIDs into their journal articles. And guess what? Nobody reads the instructions to authors. I have really good evidence. It's right there. All right. And so what you see there is like maybe a couple of publications had, an RRID or 2 in a month. And then we got SciScore in right around, right there in the middle of 2020. And you can see that percentage actually rises pretty well. And then just recently, in about the middle of last year, there was an automated email that actually started coming out from the journals that basically says, hey, if they don't detect an RRID in the, which is literally they just search for RRID, does this thing exist in your paper somewhere? And it turns out if you send them an email and you bug them until they comply, then they actually comply. So we're up at about 70% now, which is pretty cool. So thank you very, very much. I really appreciate all of your thoughts and you letting me be here and talk about RRIDs. Please use RRIDs.
our mics are on. Yeah, I can hear myself, and good to turn around, see the rest of the audience, and thank you for coming. These are really, you should have sat here from the beginning.
Oh yeah, this is much better. You guys should be up here.
So thank you again to Community for Rigor for the opportunity to moderate this panel, and I'll prime it by saying that we hope to hear from some of you in a few moments. So we'll have a mic. I'll give some questions to kind of start us off, but we invite the audience to also participate with your own questions, either now or just after the presentation. So the first question, I have lots of questions, but the first one I want to ask each of you, since we've seen tremendous progress, each of you could point to, the impact of the work that you're doing and that your communities are doing over the past 5 years, 10 years. And I want to ask you both, right now, today, what do you feel is the biggest challenge that hasn't been really cracked yet? Is it that we're on the right path and we will get to where we need to go? Or are there still some key fundamental challenges that you say, like, we should really be focused on this because that's where more effort is needed, or more innovation, or more technology? So let me start with Ivan, and then we'll hear from Anita. And what do you think is today's biggest challenge when it comes, at least to your area of working with retractions?
Yeah, I mean, I think there has been great progress in terms of visibility, in terms of a lot of tools that, whether it's institutions are using, individual scientists are using, publishers are using to find problems. I think the biggest challenge remains way further upstream of that, which is the incentive system, right? The incentive structure that you're all working under, that, pretty much every scientist, every researcher around the world is working under. And so I lay a lot of that at the feet of sort of rankings culture, right? Which is really an extension of citation culture. You all know what your H-index is, right? And Google Scholar won't let you forget what your H-index is. Well, universities are doing the same thing, right? And they like it when you have a high H-index. And, there are entire, sort of strategies that are built around increasing rankings. And of course, a lot of that has to do with citations. So I think it remains a big challenge. I think there's some really, even there are some really smart attempts, things like DORA, right? Declaration on Research Assessment, and others, but we really haven't cracked that yet. And, if I were to say, let's solve one problem in the next 5, 10, whatever it is, years, that's the one that I would hope people focus on.
And let me ask you a quick follow-up before I turn to Anita's thought about that. So in terms of that, because I definitely agree with you about incentive structure, are there any groups, or are there any universities, or do you see any places where we should be learning from this, where either particular institutions or particular disciplines are moving that direction, and they might be some early examples of what others should be doing?
Yeah, so I think, again, DORA is an example not of an institution, but it is an assessment, sort of a declaration that a lot of universities have signed on to. There are universities that are saying, listen, instead of your entire CV or all of your papers and your whole vitae, just send us your three, sort of what you think of your 3 best or your 5 best papers. And, here's a sort of, shocking thing that they might do. They might actually read the papers, right? As opposed to weighing them, or, sort of just counting, looking at their altmetric score, or whatever the flavor of the month is. And there's some universities doing that and and actually eschewing rankings. And, for example, here in the States, there are universities, and particularly obviously medical schools and law schools, graduate programs, professional schools, that are saying we're not going to take part in U.S. News rankings anymore. But it's very variable around the world, and I think we need to be cognizant. We need to recognize that, and also recognize that in different places around the world, everyone's at a different stage in sort of, and I don't want to make this sound like it's linear, like sort of some countries are ahead. They're all just in different places. And so I think we just need to take a very international, frame and lens on this, because science is an international endeavor.
All right, so let me turn to you, Nate. If you could solve one challenge, where do you think we should be directing our efforts? What do you see as important?
I think one thing that is extraordinarily important is that people care about rigor and reproducibility. And I love some of these efforts that Ivan actually pointed to. In England, you are expected to produce 5 top works, right? And I think a lot of the time we're putting out papers and they're not really good ones. And we know that. But the number of papers that are coming out is not enabling anybody to be able to read them anymore. It's just, and I speak to some of my colleagues up at UCSF where it's really, really bad because, you know, they have to have the highest H index ever. But they're just cranking out as many papers as possible. I have a colleague who, you know, created just an absolute seminal work in based on AI generated data that was on traumatic brain injury, which is now going into hospital use. This is an amazing, amazing in silico discovery. And I knew what I was looking for. I could not find it in his extraordinarily vast, you know, number of papers. So I think we're producing a lot of papers. And some of them are extraordinarily good. Some of them maybe aren't. But it would be really great if the focus began to shift a little bit from quantity to quality. And if everybody had a little bit of a shift towards quality as opposed to quantity, I think we would all be much better off.
So I think in terms of the question I was thinking about next, it's interesting that you both are sort of centering these human elements about motivations, about judgment. But let me ask my question about technology, because both of you pointed and used technology to do some things that were not possible 5 or 10 years ago. All of the different systems that you've mentioned, in fact, the interconnectedness of scientific publication and data resources that we can have, all of these automated features to link data sets to understand what's going on. What would you say now in terms of the ability of various technologies or these sort of infrastructures of digital publication? Is that being changed right now in terms of all of the use with LLMs and AI being able to help some of that? Do you see that going in the right direction? Do you see that giving us new tools? More of the same will help us to get better at some of this stuff, like the automated email that you had at the end, just reminding people what they need to do. What do you see the role of technology? Are we sort of on a steady state of accumulating those tools? Do you see new innovations on the horizon? Or on the flip side, to kind of where I heard some things going, in what cases may technology be harming us? Because also the ability to pump out and crank out work that's not very top-notch is also accelerating along with the idea that technology can fact check us. So let me start with you, Anita, and then go back to...
Oh, that's perfect. I don't know if any of you have read the NIH proclamation recently, you may only submit 6 grants. Well, apparently the reason for that is because some very smart guys went out there and submitted a whole lot more than 6 grants, all using AI. I mean, this is happening with Ivan's, you know, talking about the paper mill, right? We have grant mills, we have paper mills, we have a lot of this stuff. So we're definitely seeing the bad side of AI. I mean, it's certainly useful and it's helpful, but we're seeing a lot of the bad that comes with AI. It's sort of, you know, it's kind of like when you talk about, you know, science, great science fiction. Great science fiction isn't going to predict the car. It's going to predict the traffic jam. And we're seeing some traffic jams, right? So we've got this great AI tool or multiple tools, and now we're seeing the kind of traffic jams that come along with that, with their misuse. Obviously, I have created an AI-based tool that actually checks for Rigor items, and we're trying to sell it to journals. This, you know, declaration of conflict of interest here. But this tool is there for anybody to use, and lots of journals use it. I don't think that all AI is bad. Obviously, I think, you know, the automated emails that tell us, no, you really do you really do have to do that thing that you're forgetting to do, right? That's a really good use of those kind of systems. But generating an entire paper or grant, we've seen some of the problems that are associated with that.
Ivan?
Yeah, no, I essentially would just agree with everything Anita said. I mean, in our world, we see, as you mentioned, Jason, the sort of proliferation of paper mills that are obvious. They've been around for a long time. I mean, we know they've been around at least since the, probably 12, 13 years ago. And it's pretty clear they were definitely around before that, but they were sort of visible then. And that was before, I'm sure some computer scientist or someone would correct me and say that was before AI. I mean that sort of colloquially. Certainly wasn't you couldn't do it yourself, if you will. A paper mill couldn't just sort of plug into an LLM or ChatGPT or Gemini or whatever it is. So that's been around a while. We've seen that sort of growing, and that was kind of now AI has just sort of put that on steroids, if you will. I mean, it's like any other dual use piece of research or science or development or technology. And so, again, to Anita's point, I mean, we see these very specific cases where, for example, peer reviews are now, being written by AI, and people are waiting, and I'm going to get the details of this wrong. I apologize in advance, but essentially because I'm not a technology person, but they've essentially, authors have hidden, like sort of, I think they're calling it, like, it's not blank, it's like white text.
Yeah.
So it's sort of hidden to the naked eye, but it's not hidden to an LLM that you're now feeding that through. And so it's literally saying things like, okay, say something negative now, and now, finish the review with a positive statement or something like that. And so, we're seeing all of this. Yes, and, recommend acceptance. So we're seeing this, we're seeing papers that are written with, obviously, with, with sort of key terms. I mean, why would you see regenerate response in the middle of a paper? Unless there's a field I don't know about where that's a thing that you would write in a paper, it obviously doesn't. Why does the word delve show up in so many papers? Somebody did an analysis of this. So I do think we're seeing, and I'm gonna take your metaphor and or take your, I don't know if it's a metaphor exactly, but take your sort of science fiction, they not just predicting the traffic, but actually predicting, global warming and smog, right? Because that's what we're people use AI slop and all of that. I do think, though, there is, there's a clear role for some of these, whether it's, I don't even know if they're AI or, LLM, they're actually just automated systems. Those to me don't require, some sort of sophisticated computer science. There is a role for that. But even there, like I just came back from the peer review Congress in Chicago. That's a meeting that happens every 4 years. Fascinating. I mean, it's my kind of geekdom. I just kind of soak it all up for a couple of days in Chicago. And someone had done something called a retractabot, right? Where they alerted people, they pulled it in, and this was before our database was available, so it took so long. This is another story, but it took a really long time for the protocol to get accepted and all this. So by the time they did it, it actually sort of eclipsed itself. But what they found is that when they alerted people, just an automated, this thing, retractabot, alerted people that they had cited a retracted paper, they got some combination of anger, like, why are you sending me this email? Like, who are you? We got some of those, even though we had nothing to do with it. They assumed we had something to do with it. But the sort of overall finding was that it had no impact, right? So in other words, it did not, over the period of this study, it did not change behavior at all. And again, I think there's some other confounders there, which they acknowledged in the paper, which is that, again, the time it happened, et cetera. But I think we also have to we can't rely on whether it's an automated tool, whether it's AI, whether it's whatever you want, whatever it is. It's, for example, at the Retraction Watch database, and people assume that it's automated, right? They're like, well, it must be automated, because how do you get thousands of retractions into a database every year? And I'm like, nope, it is not at all automated. I mean, there's a vague semi-automatic process that if a publisher or a journal retracts like 100 papers at a time, we kind of have a way to ingest that into something that doesn't go directly into the database, but it gets checked and kind of, but everything in there is checked by a human, actually by one of a couple humans. And there's still mistakes, absolutely. But I think if we give that up, and if we rely, on these sort of automated systems, I think we're going to just chase our own tails, or, whatever you want to say about that.
Well, I have many more questions, but I want to check the audience to see who would like to. I see Shai in the front looking for a microphone, and we'll try to take as many of those questions as we can.
Thank you both. It's a very interesting conversation here. And I have two questions for Ivan. The first slide you showed where, kind of skyrockets the number of retractions. Does that include paper mills or exclude them? And if it does include them, what would it look like if, we didn't include them? Because I think that's like a different ballpark. And the other question is, everyone talks about number of retractions, but what does it look like if one looks at the number of PIs whose papers were retracted? Because we know that there are many that have multiple papers retracted because they're dishonest. But if you just count number of PIs and what percentage of PIs have retracted papers?
Yeah, it's a great question. Two great questions. So the first is the sort of short answer is yes. That the spike is almost all paper mills, the sort of extreme spike. And I chose that figure. There are others, and I also have a figure I didn't obviously use today that goes way much further back in time, and I think gives you a better sense of things. So essentially, and I don't know if anyone back in the room can see me, but see where my finger's doing, but you start back here at 20, 25 years ago. The rate was about 0.02% of papers being retracted. So I want to be clear that yes, it's a spike and it's an explosion, if you will, but it's it's still, as an absolute rate, it's still quite small. So it's 0.02, and now we're about 0.2. So it's actually an order of magnitude, but that's 1 in 5,000 papers. This is 1 in 500 papers. So it's still pretty small. But the spike has come down. In other words, if you take out the Hindawi event, right? Then it was sort of like a meteor, right? And then if you take that event out, the trend is absolutely, it still continues to rise, but at the rate it was rising. What'll happen after this, I obviously can't predict, but I do think it'll continue to grow, but at a sort of, I don't know if that's organic exactly, but it's sort of, that rate. So it's again, it's about 1 in 500 papers. We estimate probably 1 in 50 should be retracted based on guidelines. And a lot of them just aren't, and that has to do with why people don't want to retract and publishers don't want to retract and what have you. So it does include paper mills, but again, the overall trend is definitely, for an increase. I think, and your second question, which is really interesting also, is, what does it look like if and people have started doing this. I mean, what we love, I get an alert, not quite every day, but most days, about someone publishing a paper that relies on the database, and we'd love for everyone to do that. It's terrific, and we're not set up to do research, so we're glad that other people are using it. And so people have looked at that. They've looked at gender. It turns out that men are much more likely to retract papers, and also much more likely to retract them for fraud. We have a leaderboard of people, which I think gets to your question, where the person with the most retractions in the world has retracted 221. He's had 221 papers retracted. So sometimes I'll ask people to raise their hands. I won't ask you all to do this, but how many of you work in labs where you've published, the lab head or whomever has published 221 papers? And that's a lot. In some fields, I guess it's not a lot, but sorry, you won't be able to be on the leaderboard. I'm sure you're disappointed. But if you add up all the heavy hitters, if you will, you were left with most, and you remove them. Most people have never had a retraction. I mean, that's, if you were to look at the mode, or I guess it's probably even the mean or something, but like most people have not had a retraction. There are 60,000 and there are hundreds of thousands of researchers, even though each paper obviously has, again, you can burrow into these details ad nauseum, and don't tempt me because I obviously think about this stuff. But we also have a list of Nobel Prize winners who've retracted papers, and there are 20 people on it, right? There's someone kind of down the road from here in another state, but at a very prestigious university, who is a Nobel Prize winner who's retracted, I think it's still 13, there may be 15, but 13 papers. And so, yes, it's still a pretty rare event, and if you take out the mass retractions and what have you, so if you were to normalize, or I don't know if that's the right word, but if you were to look at, overall, most people still haven't. But at the same time, it's not and I guess the last thing I'll say about this is what we've come to realize, and we came to realize this fairly quickly, is that retraction rates, or just retraction in general, is a really good proxy for attention. It's not necessarily a good proxy for the quality of a field or even of a person's work. I guess the person's work maybe a little bit more, but without attention, in other words, if people are speeding on a highway and there is no radar gun, then it's not like nobody's speeding, but nobody will, it looks as though statistically nobody's speeding. Whereas the attention that what tends to happen in cluster definitely has an impact.
We are at time, unfortunately. We have one more. We have time for one. Great. I'm not authorized to go over, but
I'll make this quick, and I want to talk about some of the bigger implications of reproducibility. I think most of us are pretty honest scientists, and we welcome efforts to improve reproducibility through all these mechanisms. Although there's many reasons why it's difficult to exactly replicate an experiment, and scientists in the field who've been around know that this happens, and whatever we can do to improve that, it's fine, but it doesn't necessarily mean fraud. I am concerned that, again, as you alluded to, the general press has a slightly different interpretation, that they assume that this is malicious, and I worry that it's being used to undermine confidence in scientific progress. So do either of you have suggestions as to how we can, keep the value of what you're doing without having it be used to undermine confidence in science?
That's a great question. Anita, could you start us with that?
Sure. This is a very tricky thing. And I think this is one of the biggest problems that all of us are going to face. I mean, the answer cannot be, we just can't talk about rigor reproducibility, right? We have to talk about it. We have to police ourselves, if you will, because as Ivan was saying in his talk, somebody else will come and police us for us, and we really don't want that. But always when I speak to the press, like Ivan, I'm as careful as possible to with my language so that it can't be taken too far out of context. And I do try to focus a lot on the positive stories as well. And those positive stories are, things like, well, we uncovered this problem, we figured out an intervention, and here's how it's working. Here's what we're doing to actually address this problem. And then it's really hard for them to say, well, this is just bad, right? But I try to stay away from just studies, even looking at things like, oh, here's a problem and there's no solution sort of studies. I like to say, what would be the intervention? Is there a way that we can actually fix this? And what would be the right lever to use to actually fix something? And maybe not all levers are great, but defining those levers and describing them, I think, is a way to also couch this in a, yep, there's a problem, it was discovered, here's what we're trying to do to fix it.
Yeah, I would sort of look back at history a bit and say, some of you may be familiar with, the 1980s, there were a couple of pretty bad scandals that happened in science. And, Dan Koshland, who was then the editor-in-chief of science, got up in Congress because they were holding hearings and said, well, I mean, I'm paraphrasing, but he had this editorial, which you can look up, and it said 99.99999, and it went on for way beyond, those of you who remember the Dial soap kind of, commercial, percent of research is, honest and all of this. And that wasn't true. And it doesn't mean that 90% of it was faked. It means that it was somewhere larger than zero. And that, I think rightfully so, he was rightfully, sort of criticized for that. But that was the time when you came up with, the federal government came up and Congress came up with a lot of the regulations and all sorts of things. We found, and so the word people use is weaponize, right? And so people, they weaponize our work, they could weaponize anyone's work. They can weaponize whatever they want. And weaponizing is generally thought to be ill-intentioned, badly intentioned. And so I think you have to sort of say, listen, for example, we have now this gold standard science executive order, right? Which I think is making a lot of people feel a lot of things. I'll just put it that way. And so if you look at, and I'm not saying there's not some things in there that are just way out there, but if you look at the core of it and you look at what's there, it's a lot of things that a lot of us, and probably a lot of you working for Rigor, have been saying for a long time. The problem is, and this is a message I try to give, because reporters, sorry, I guess maybe I'm the only one in the room, so I can say this without getting, some of the things thrown at me, but reporters are just as lazy as the rest of us. And so if there's a reporter they can call, they know that I can talk the language they want. So I've gotten a lot of calls about that the gold standard EO and all of this, and about particular RFK Jr. and sort of Secretary Kennedy, et cetera. And so what I say is, look, we need rigor. We need more rigor. Nobody disagrees with that. And people do practice a high level of rigor, but it needs to be applied. You need to apply all those principles to studies that sort of quote unquote agree with your priors, and which sort of support what you think is true, as well as oppose your sort of beliefs, or beliefs is a bad word, but sort of what you think is true. And since I've said this publicly, I don't think it's going to sort of suddenly the walls aren't going to cave in because I'm saying it here. I've said it in public venues. Secretary Kennedy only applies all of that to work that doesn't agree with what he wants the world to be, and I think we should keep pointing that out, because it's a way. I'm not saying it's going to solve all these issues, but it's a way to say no. We've been thinking about this stuff for a long time. I don't mean we. I mean scientists and researchers, policymakers. The world's been thinking about this stuff for a long time. Thanks for coming along for the journey, but we apply it to everything, not just studies that don't agree with us, or whatever the term is.
Mm-hmm.
Well, good luck.
So, yeah.
We actually have time for more.
Oh, okay. Let's take one or two more if there are. If not, I'll jump in with that. Hal over here has a question.
Hi, I'm Hal. I'm part of the Community for Rigor's staff. I'm going to ask a question. I don't know if Sarah's here. Sarah, are you in the room? Not yet. Okay, I'm going to ask a question on behalf of Sarah, who is developing educational materials on identifying rigor red flags. And I guess my question to you two is, you talked about retractions and you talked about RRIDs. What are flags in research papers that aren't things that you've already talked about? What are things that are indicators that aren't easily checked with some of these tools that you've talked about?
There's a whole industry of this stuff now, right? So, and I don't think that's all positive. I should be clear. There's a sort of gold rush of lots of startups that are, and I'm not impugning startups here, but in the last, I would say, a couple of years, where everyone suddenly got really anxious and up and down, jumping up and down about paper mills. So there's all this effort at looking for signals of paper mill activity. That's not bad. I think it's rearranging deck chairs, if I'm being honest. But so I think that there actually there are tools like that. I would be very careful with. Even the red flag sort of metaphor, what have you. It's the problem is you can end up catching a lot. You sort of, again, here's more metaphors family, but sort of bycatch, you're fishing for whatever, and you end up killing a lot of dolphins. And I think that if we're being honest about this, there are parts of the world that are going to get swept up in that in ways that frankly, the wealthy Western countries are not. And I think we just have to be honest about that, because a lot of these flags, and this goes back to looking for what are called quote unquote predatory journals, predatory publishers. Unfortunately, that overlapped a lot with sort of new publishers, and so there are things you can look for, and that again, Anita probably has much more sophisticated ideas than I do here. But I would be sort of all of those can be gamed or end up having bycatch that you don't want. And so I think there isn't really any sort of way to replacement for just reading the thing, and then maybe asking for someone's data. And here's a red flag that I actually often look for when we're reporting on stories. If people want shared data, that like it doesn't mean that they faked the data. It just means I don't really know what happened, and that's that's a way to look at that stuff.
Can I throw something in front of your reaction, which is essentially at a certain point, you've caught some of the easier things because those things were the easiest ones to catch, and automation can help. But I wonder if it also speaks to the nuance that's going to go with different disciplinary specific. I don't mean if we're not using the term red flags, but you used the term earlier of a mistake that only this person would know because they know the field or they know their work well enough. And I wanted to just say that because we are in this thing called a community for rigor. And there really are maybe some community aspects into, you're going to check a certain paper or a paper a certain way if it's from neuroscience, that you're not going to check it that same way if you're in experimental botany. So I'm curious what your thoughts are to help answer Hal's question, but also the idea of communities being self-policed, not just science in general.
Yeah.
So could you speak to that
Yeah, no, absolutely. I think this is a really good point, that certain communities will have certain levels of standards, and that works both ways. That's both good and bad, right? Botany is not going to do Western blots, generally speaking, right? Or chemistry will not use a lot of animals. And actually, this is interesting because when you look at chemical papers, they very often forget to put in an IUCAC statement when they're actually using animals, and they should be putting in that particular statement. So there are things that come out from sort of the edges of a community that are often missed. But within that particular community, within that journal, they're going to be much more rigorous about the things that they know are really important to those sets of experiments that community generally does and understands. All of us can do better, right? But what I wanted to actually also follow up on some of the other points that were recently being made. There's actually it's called Signals, and I can't remember which publisher this is coming out of, but they've taken a lot of these tools and they're trying to put these tools all together in a single platform, so that you could check for different kinds of things in the paper. Is there too much self-citation? Is there any evidence of image manipulation? Are there signals where there's a lot of retracted papers being cited? And there's a whole slew of these things that are out there. Those would be definitely red flags. The things that I would not want this community to consider are those red flags. Because if we make a nice list of those red flags, then the paper mills are going to go through that list. And they're going to say, I have a wonderful list of red flags that I'm going to now, make sure that my paper mill paper passes, right? So actually, I think we don't want to look for those red flags. But what we do want to do is go to the community and say, what is the level of reporting? Is the data available? Is the code available? Are these sorts of things there? And actually, in a couple, so I think Marianne Martone has this beautiful slide, which I didn't bring with me, but it was a tale of two retractions, right? In the one case, there was a retraction because there was a problem in a data set and it was discovered by some undergrad working at a different university, and the head of Stanford kind of came down because of that. But it was embarrassing. It was absolutely embarrassing, and there were consequences. But the data was there for people to look at, and it's like, oops, a mistake was made. That's fine. And then you see, some of the real cases where there is no data available. And that's where you really start to question, is it fraud, right? Is it an honest mistake or is it fraud? And I think that the difference between those often is couched in, is the raw data available? Is the process data available? Is the code that was used for that? And I think for those kinds of things, we can all do a better job because that's all transparency. Code availability, data availability, which materials are used, Those are all things that I think everybody can agree on. These are critical to every study.
I'll just mention one thing that that Anita reminds me of. Signals, I think, is part of dimensions in digital science.
Yeah, I thought so too. I wasn't 100%
So it's, but the other one, which is not commercial, it's some academics who've done it in France. It's called the problematic paper screener. Have you seen this? So they have all sorts of signals, lowercase s, I guess, but things like, they have these clever names, like feet of clay means it cites a retracted paper. They have something called tortured phrases, right? Where this is when they have like sort of a term that is clearly sort of sent through, maybe it's an LLM, maybe it's something else, a translation to try and fool the sort of detectors, and you end up with, instead of breast cancer, you have bosom trouble. I like, there's also like, instead of kidney failure, you have renal disappointment, which I think is sort of poignant, but as a somewhat former clinician. But yes, I mean, those are, and they're fun, and actually I think it's useful just because people are aware of it. But again, you could always train something to scrape those out, and to sort of make sure that you weren't citing retracted papers or something. But
There was one back there.
I think Shai had his hand up first.
No, you go ahead.
Great, thank you both. Really enjoyed your insights. I'm Ben Kolber from the University of Texas at Dallas. I just wondered, maybe, Ivan, if you could talk a little bit about whether the rates of corrections are the same as the rates of retractions, and what that tells us about people's willingness to make corrections and that sort of thing.
yeah, it's a great question that I actually just don't have any data for. So it's easy answer, or I'm ducking it. But yeah, there are. I mean, look, there are always at least an order of magnitude more corrections than retractions. Whether that's, I just, it's a great question that I wish I had the answer to.
So it's me again. So I found this conversation in the last few minutes fascinating, and I'll explain why. So I'm in the Office of Research Quality at NINDS, and it's a taboo in everything we do to associate rigor and transparency with misconduct. And we never even talk about misconduct because the numbers are small. So, and what we had here, is a question about red flags. And my understanding is that the red flags we're talking about is whether the work was done rigorously or not about misconduct. But the answers, you interpreted, as talking about misconduct. And that's why I think it's incredibly important to keep these two things separate. Mm-hmm. To focus on rigor and transparency, because transparency will help us figure out the rigor, and to leave misconduct aside because it's a tiny, as you pointed out, it's a tiny fraction of everything that we're experiencing. The rigor is a much bigger issue.
So then
I could tack on to say, like, what is your list of top tips for reading a paper and really understanding what it is and its rigor and its meaning?
Well, I mean, the sorts of things that we haven't done yet that we would love to do are to look through all the rest of the, really well-known guidelines, right? So right now we're working on the RRID 10 to get that implemented into our software tools. But there's Consort, there are Prisma, there are all these other guidelines that I think give us a really nice place to, hang those kind of things that we should be looking for. And, obviously I am of the belief that automated tools can help us point those out. But in terms of, the sorts of things that we can find with rigor, I think a lot of them have been kind of ensconced in these guidelines. That's where the community has already spoken, said, okay, we think that it's really important for our kinds of studies to, go through this list of things. The place where I have never, ever, ever seen anything. And I've been asking incessantly. And my husband actually happens to be a chemist, and he's never answered me either. So I think it's not just him and our relationship that's in trouble. I think it's just that chemistry doesn't actually have really good guidelines. Because I've been looking, and I'm a guideline person. I love guidelines because they tell me like something about a field in terms of what's important, and chemistry just has nothing. And whereas, you know, we have Consort and we've got updates to Consort, we've got the ARRID guidelines, which, you know, for all the animal studies and everything else, we just don't know what makes a really good, rigorous chemistry study. And I would love to know, actually. So if you have any friends or, you know, or significant others or loved ones or anybody else in chemistry, maybe ask them.
So can I ask a question then, because of what the purpose of C4R is? You know, obviously we don't want scientists learning about rigor when they get to publication and then they're confronted with, that's not where we want the education to be happening. Do either of you see good examples of, you know, the idea of rigorous practice actually making it into the curriculum and in a more formal way versus trying to learn from mentors? Do you see need for that? Is that something? I mean, I just think about someone I know recently was you know, not a research scientist, but in the sciences, and taking a photo, and you know, just didn't know about image saturation, and didn't get the perception. And you can imagine an undergraduate or graduate student putting a photo in a PowerPoint and not actually thinking, am I doing image manipulation? I meant to make it clear that you could see this, but I'm actually changing the data. Where do you think this belongs, or do you see examples, or is there a need for it? I'm assuming you'd say yes, for this to make it into the psyche of young researchers as they're, you know, sort of learning, because nobody's thinking about retractions until you're actually many years into your you know, career, basically, at that point. So what do you think about the state of education as far as rigor and reproducibility and those things making it into teaching?
So, I mean, I would say the bad news is that there isn't a lot of evidence that current, and I'm sorry, Shai, if this may not be a great thing for you to hear, but you probably know it already. The sort of RCR mandates, you know, RCR training mandates that, you know, the federal government has, any federally funded research, there's essentially no evidence that does anything.
We just have to, well, it takes 6 or 7 or 8 hours of me watching a video.
Right. Oh, it does something to your day. It
Yes,
does something
exactly.
to your schedule. I get invited in to give some of those guest talks and things, which I'm happy to do, but I think more for entertainment value than for actual rigor.
And for metaphors.
Yeah, definitely for metaphors. Yeah. So I think that's obviously the bad news. But again, not surprising anyone. Actually, I've never gotten applause for. I've gotten applause for certain kinds of statements. That
You're
one,
in a special room.
no, thank you. I'm putting that in my slide decks now, so that because I like applause. No, but I think that so we work with a group called NCPRE sometimes. They're at University of Illinois, Urbana, and their whole focus is on culture and on lab culture and this is sort of where I know that knowing my own. So in my day job, I'm at the Transmitter, which is part of the Simons Foundation, editorial independent. And there's actually, at the Simons Foundation, there are about 500 employees now. Give or take, I think it's about 300 of them are working scientists, computational scientists, but in different fields. And whenever we sort of have meetings about, and as managers, sort of how to, you know, think about the foundation, how to think about sort of working in, and these are all really, they're amazing, brilliant scientists and wonderful people, but they always bristle because they're really academics. It's just sort of a different place they're working. Bristle at anything that sounds like management speak, anything that sounds like, oh, we're going to send you to management training, we're going to send you. I know that, and I understand why. But if we can find a way, and I think NCPRE at Illinois has done this, they have great programs and all sorts of like videos and things like this. If you can find a way to make that actually work, there are some good practices about organizational, whether it's organizational psychology, which, okay, asterisk, because we know that that field's had some problems, right? But there is sort of there's something there. There's something somewhere that is about thinking about, bringing people. What do you do when you onboard someone to a company or to a new department? And again, even that sounded very corporate. I'm sorry, but at the end of the managerial, but it's what we do. And so that, again, forgive me if I just don't know this, but I think I do. That sort of acculturation, and then what do you do on an ongoing basis for development? That's not a thing. It's not a sort of core thing that I think a lot of academic institutions think about. And if you couple that with bad incentives, and you mentioned in passing the Martessier-Levine story, and that's not a story of the senior researcher committing misconduct. It's a story of a senior researcher creating an environment in which that was encouraged and not doing enough to correct it, right?
Yep.
So that's pretty toxic. And so, I think if we can do something along those lines, I'd love to at least try it.
I would love to turn this back at the audience, because this is the audience that's going to have to answer that question, right? It's you guys. It's not us up here. I have my tools. Ivan has his tools. We're doing the best we can with what we've got, but we definitely need more of us. And you guys are the hopefully the group that can help lead the next generation towards actually implementing some better practices inside of universities. I mean, I like to think of this a bit like a pendulum. So when I was trained, apparently students would duck out of the way so that my advisor wouldn't see them, because he was known to be kind of mean, let's say. But he was also a very good scientist. He was very rigorous. He was absolutely top notch. And one time when I was doing my recordings, I'm like, oh, I've got all my recordings and everything, and I forgot to calibrate. And he walked in there and he looked at my recordings. I'm like, oh, I think I've got something. And he's like, where's the calibration? I'm like, oh man, I forgot to do that. He literally ripped it. He ripped my entire experiment up and he said, you have nothing. Do it again. Which, it sounds really kind of mean, but it was exactly the right thing to tell a young graduate student, right? You have nothing. Go do it again. And I'm going to rip up this, at the time it was great because it was a physical piece of paper, so it was very dramatic. He just ripped it all to shreds and stomped on it and walked out. Which, is a good way to tell graduate students that they should probably calibrate all their experiments before they do. And maybe you aren't a PI and you're not going to be quite that dramatic, but maybe a little drama will make your students remember. I don't know.
There's a training about that we took that says we shouldn't be
we
shouldn't be intimidating, but the spirit of it clearly made an impact.
That made an impact on me. But it's sort of like when we published papers back in the 80s. Actually, a lot of those were published with really long and detailed method sections as much as they could be. I mean, they didn't have all of the things in there that they probably should have had, but the method section just got longer and longer, and it was great. And then we had these things called page limits, and then we had these things called Nature and Science, and they really shrunk the method section. So really, the whole paper was just a 2-page advertisement for your lab, as opposed to a paper. And then Cell Press actually turned that around and said, all right, we're sick of these advertisements. We're actually going to do something. We're going to give you all the space you want to do your method section. There's not going to be ever any page limit on the method section at all whatsoever. And they put in that big, beautiful STAR methods table, which has all of the reagents listed in a table, and they make you do that. And so that started to, again, shift all the big publishers. So I think it's a pendulum. It's sort of like, we were doing a good job, and then we went through a period of just, removing the methods section essentially from a scientific paper, which becomes advertising. And then, I think we're starting to get it back. And so, we're part of that, let's get it back. And apparently in the training, you shouldn't be ripping up your students' work, although, again, find some way to be
Find some way
effective.
to be effective. Well, I like that because I'm told we now have to end. So find some way to be effective. I like that as a concluding thought for this. So this has been amazing, both the talks, presentations, and then the discussion. And I hope that this is a great way to kick off the next day or so of the conference. So thank you everybody for joining.